All right. This is the test review. Yes, we have a test tomorrow. That's why we're doing the test review today. We have a test tomorrow on 12/13, which is a Thursday. Same amount of questions. It's always like around 23, 24 questions, but it's always 100 points, okay? So it says the table at the right shows some points from a quadratic function, f of x. What is the value of x when, y'all can't see that. What is the value of x when f of x equals 6? So remember what f of x is? That's telling you that the y equals 6. So look for where the y equals 6. There's a place right here. And keep looking because remember quadratics have symmetrical pairs. So sometimes there's going to be two answers. So there's two answers where the x equals 6. Go ahead and make sure you circle that one. I'm sorry, where the y equals 6. It says when graphed, which function would appear to be shifted 4 units down from the graph of this one? Remember, not 4 units down from the quadratic parent function, but from this one. So this one, let me draw a little picture. It's already, and you can put it in your calculator if you want to see this. If you put this in the calculator, you'll see a graph that's right here, a parabola that's right here. And they're telling you it's shifted 4 units down from this one. Right now the vertex is here. If I go down 1, 2, 3, 4, now my vertex will be at the what? -1. So I'm looking for which one of these has a vertex of -1, which will be this one right here. Because there is no parentheses here, so there shouldn't probably pop up parentheses here unless I'm doing a right or a left shift. All right. What are the zeros of the graph below? Remember, zeros are the x-intercept, which I keep saying many times. Another thing is it must have a 0 back here. So one of them is at -3, and if you keep going, since the vertex is on the y-axis, it's going to be symmetrical, which it will be a +3 over here if you keep going. So one of them is at -3, the other's at +3. The only reason why they're opposite, negative and positive, is because the axis of symmetry is the y-axis. Number 4, we talked about a lot of applications yesterday. A toy rocket is launched from ground level with an upward velocity of 64 feet per second. Its distance from the ground can be determined from the equation. Be happy, they give you an equation. That's your y equals 64x minus 16x squared. H, they're telling you, is the height in feet. And t is the time in seconds. So they ask you a whole bunch of questions about it. The rocket was in the air for blank seconds. That's the landing point. When did it land on the x-axis? That means it was in the air for 4 seconds, because this is all the air. This is the air, boom, lands on the ground on the x-axis, okay? The maximum height of the rocket was approximately blank feet. Maximum height, they're only asking for maximum height. A lot of people were giving me the full vertex. The vertex is 2, a little bit below the 65, so I'll say 64. But they don't ask for the whole vertex. They only ask for the height. Which part is the height? The 64 is the height. So if you give me 2, 64, that's wrong, because they didn't ask for the vertex. They asked for the height. The rocket was at a height of 30 feet at blank and blank seconds. Remember, symmetrical pairs usually have 2 y values. Or, I'm sorry. Yeah, height. That one's kind of weird. So this y value is for this x and this x. So yes, they have the same y value. I shouldn't have said 2 y values. I should have said the same y. So for the height of 30, what is the x? And what is the other x? And it looks like it is about halfway through. So I would put 0.5 or a half. And this one is 3.5. First it went to 0.5 and then it returned to 30 feet at 3.5. Remember that word return? It means that's the second time it got back to me. How would the graph of the function x squared, okay, so we're no longer talking about that. How would the graph of the function y equals x squared be affected if the function were changed to y equals x plus 5 squared? This right here, this transformation is happening on the inside of the parentheses, which means there's a horizontal shift. We do the opposite of the horizontal shift, and that would change. That would be changing the domain. However, opposite of the horizontal, it says +5, so how many units? It would be 5 units which way though? Left. Because if it's a +5, it's to the left. If it was a -5, it would be to the right. What is the vertex of the graph of this quadratic function? Remember, vertex form. A lot of people were like, Miss, what's vertex form? Vertex form is this because it shows you the vertex. The opposite of the h is the x coordinate. And the k, the exact of the k, is the y coordinate. So vertex is opposite of h, not -3, it's a 3, because it's always the opposite. However, the one out here, that's what the exact same number. Opposite number, exact same number. Opposite h, same k. Axis of symmetry is the x of the what? Vertex. Thank you. So x equals. On the assessment yesterday, a lot of people were just writing a 3, a measly old 3. And I marked them off because I don't know if it's x equals 3 or y equals 3. Okay. Domain for this one, since it's an equation with no other information, it's all real numbers. Number 7, a book was dropped under a motion detector. The following data was collected. Which of the following best represents the relationship between the distance from the motion detector y and the elapsed time x? This is a calculator problem. You're going to put this in the calculator, press second graph, and well, because these are all like 0.1, 0.2, 0.3, you're going to have to change your window. You're going to have to change where it starts. Okay. So, I mean, you could jump to second window, put in 0.1, and make sure 4.66 is lined up with it, and then you have to check all of them. So we'll go back to that one at the end. The table below shows some points from a quadratic equation, h of x. What is the range of the function? So the first thing, in order to find the range, what do you need to know? Vertex. So start matching your symmetrical pairs. 6 and 6, 9 and 9, 14, 14. Vertex is 0, 5. Because the y of the vertex helps you to understand which number needs to be used for the range. The y of the vertex helps you set up the range. So we know the y's have to be something about that 5. The other thing is you have to figure out, is it going to be less than or equal to, or is it going to be greater than or equal to 5? By looking around the 5, what's happening? The numbers are getting what? They're increasing. They're getting bigger. So we need to use y is greater than or equal to 5. So circle your answer. What is the range of the function showed on this graph? So be careful with this one because once again they are asking about range, which is the y values. Which y values are being used? This one cuts off here and cuts off here. Be careful. It's not just a table or it doesn't have arrows. So what is the lowest y value being used? Do they use this down here? Nope. It starts right here at the vertex, which is at what on the y-axis? -4. That's where the y equals -4. And then up here, what is the highest value being used on your graph? The 5. However, notice that open circle on the 5. Since there's an open circle on the 5, you do not use the equal to with it. Like here, no. This would have mean it had a closed circle. I'm sorry. If it has an x, that's talking about domain. Why would you even answer that? This x is talking about domain. No, the question asks for range. So it has to be one of these, and it's going to be D because the 5 has the open circle, the -4 is closed up. All right, that's the first part of the review.